So let me help you figure that out. I told you at the beginning of the period that Pascal's triangle, Blaise Pascal, his triangle, I mean, this is it, and that's how you build it, but he developed it not for what we just did, not for expanding binomials. He developed it for basic probability. Here's what I mean. If you flip one coin, there is one chance that it'll land on heads and one chance that it'll land on tails. Would you agree with that? If you flip two coins, there's one chance they'll both be heads. There's one chance they'll both be tails. But there are two chances that you will get one of each. You could get heads then tails or tails then heads. All right, I'm going to do one more. If you flip three coins, you could get all three heads. One way to do that. Head, 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 that's it. One way to get all three tails. But there are three ways to get two heads and a tail. Do you see that? And then similarly, there's three ways to get two tails and a head. So the number of heads and tails corresponds to the powers on your letters when you expand. See? How many heads? 3. How many heads? 2. 1, 0. See how that works? So, find the probability of rolling a die 5 times. That's going to be the 5th row of our triangle. And getting exactly 1 3. So we're going to do the experiment, rolling a die 5 times. And we want to get exactly 1 3. Now think about that for a minute. If I roll a die 5 times, could I get 5 threes? Could I get 4 threes? Now those, I'm going to spread these numbers out a little bit. Those of you that are confused by that, this is 4 threes. Because I could get 3 and then other numbers. I could get other number 3, other numbers. See how there's 5 ways I could get a 3? See, that's 5 ways. I could get a 1st, 2nd, 3rd, 4th, or 5th. So that's what that means. 4 threes. What do you think this one means? 3 threes? 10 ways to get 3 threes? Ways to get 2 threes, 5 ways to get 1 3, and 1 way to get no threes. When you roll a die, you either get a 3 or you don't. Binomial. 2 things. Yes, no. I want 1 3, so that's this number right here. This was 5, 4, 3, 2, 1. So 5 ways to get 1 3. Now in the problems that we just did, we had an X and a Y. In these problems, we have get a 3 and don't get a 3. What's the probability I'll roll a die and get a 3? 1/6. And I want 1 of those. I want 1 3. What's the probability I won't get a 3? 5 6. And I want 4 of those. Remember, I'm rolling the die 5 times. So if one of them is a 3, the other 4 are not 3s. And that right there, this guy right here, is the answer to the question. So 5 times 1 6. And then 5 6. 2. Might want to practice typing that in, make sure you can. Does everybody get this 24 or 2? All right, let's do the next one. I know this is a little confusing, but you'll get it figured out. You'll get it figured out. We're rolling a die 5 times, so that's why I'm sticking with my 5th row. If I were rolling it 6 times, I'd be going to the 6th row. However many experiments, they're called experiments, rolling a die, flipping a coin, whatever the activity is, however many of those you're doing, that's the row of the triangle you're going to. Okay? Now this time, it's all about getting a 4. So think about this. If I roll a die 5 times, I could get 5 4s. I could get 4 4s and 1 knot. I could get 3 4s and 2 knots. I could get 2 4s and 3 knots. 1 4 and 4 knots. And 5 knots. So no 4s and 5 knots. Expand your brain. These are like the exponents. See how you have 5 and 0? And then you have 4 and 1, 3 and 2, 2 and 3, 1 and 4, 0 and 5. Those are like the exponents. Only they're standing for something. How many 4s am I getting? How many other things am I getting? Okay, the problem says no more than 1 4. What does that mean? No more than 1. 1 or, keyword or 0. So I could get 1 4 or no 4s. Now, 1 4 is right here. I got to do these separately. Can't go together. So 1 4 is 5. That's the number in the row. And then I'm going to get a 4. What's the probability of that happening? 1/6. And I want 1 4. So 1/6 is the probability. 1 is the exponent. But remember, I'm rolling 5 times. So if I get 1/6, then I must be getting 4 knots. Right? What's the probability of not getting a 4? 5, 6. And I want 4 of those. So that's the row, or that's the number from the row that represents my situation. 1/6 is a 4. 5 6 is not a 4. 4 of those because I rolled the die 5 times. Right. Or no 4s. Well, no 4s is right there, right? So it's going to be 1, 1/6 to the 0, and 5/6 to the 5th. You don't want any 4s, so your 1/6 gets a 0. You want all 5 other things. Does that look okay to everyone? Now, that's going to be a number just like this was. That's going to be a number. What am I going to do with those 2 numbers? Huh? Add them, absolutely. Or, when things are ors, we add. When it's this or this, we add them together. We want the total. Let's see if we can get that.
5 4s.
Yep.
How did you figure out that?
We're going to do another one right now. We need you.
what I got. That's what I got.
Okay. Last one on this page. We're gonna roll the die 5 times, so here are my numbers again. And this time, it's all about getting a 6. So this would be 6 sixes, or 5 sixes, I don't know, rolling it 5 times. So 5 sixes, this would be 4 sixes, 3 sixes, 2 sixes, 1 6, and no 6s. Everybody okay with that? Now obviously, if there are 2 6s, there are going to be 3 non-6s, because I'm rolling 5 times. Alright, now what do I want? Now, what does that least one mean?
One or more.
1 or more, oh my gosh. Oh my gosh, so wouldn't that be all of that?
Yeah, it could be.
A lot of numbers. Literally be everything.
Wait a second. Jimmy, you're almost there. It would literally be everything except that one. So what if I found that probability and subtracted it from 100? Would that give me the whole rest of the line?
Because 100 is 100%.
100%. Right? 100%.
Right?
Right? Or if you're using decimals, you subtract from 1. So that would be easier than doing all of these individually. So let's find that one. Now that's the probability of no 6s. So the probability of a 6 is 1/6, and I don't want any of those, right? The probability of not a 6 is 5/6, and I want 5 of those. Remember, I'm rolling the die 5 times. So no 6s, 5 other things. That is not the answer to the question. Remember, that's this. You're gonna subtract that from 1, and that's gonna be the answer to the question. All right, so what do we get? I got 0.598 as my final answer after I subtracted from 1. So in math land, we call that kind of going in the back door. Instead of finding what I do want, I take 1 minus what I don't want. If it's easier. Alright. Almost out of time, but let's get number 5 started. Alright, we're gonna get number 5 started. You're randomly going to guess on a 10-question multiple choice test. Each question has 4 options. Okay, so stop and think. You're going to guess on the question. You're going to get it right or you're going to get it wrong. What is the probability you get it right?
1 out of 4.
1 out of 4. The probability you get it wrong is 3 out of 4. Okay, so this is exactly like rolling the die. Exactly. Only that was 1/6 and 5/6. Same idea. I am going to do this 10 times. So therefore, I would need the 10th row of the triangle. Well, I had that sort of written out, but I erased it, but that's okay. I don't want that whole row. I just need to remember that 10C10, the first number in the row, means 10 right. 10 questions, 10 of them right. The next number in the row would be 10C9, 10 questions, 9 of them right. Next number in the row, 8 right. And here's the one I want. That's the number I need, 10C7. So what is 10C7? What? 120. So I'm gonna start with 120. Now, I need to multiply that by the right and the wrong probability. So 1/4 and 3/4 in this problem. In our last problem, it was 1/6 and 5/6. In a heads and tails problem, it's 1/2 and 1/2. Okay, now, how many did we want to get right? 7, which automatically means then we're going to get 3 wrong. So here we go. Oh my goodness. 0.003. Which means you have a less than 1% chance of passing.
If you get 8 or 9 or 10 out of 10,
Mhm.
so would that just be less?
Yeah, no, it would be more. It'd be a little higher.
Really good.
It'd be smaller numbers. All right. At least 9 correct.
All 10 correct.
What does at least 9 correct mean? 9 right or 10 right? With our last problem of the day.
That could be.
What is 9 right gonna look like? 10C9 times 1/4 to the 9th and 3/4 to the first. Or 10 correct. What's 10 correct look like? 10C10, 1/4 to the 10th times 3/4 to the 0. You don't actually need to include that one if you don't want to, because what's 3/4 to 0? So you don't need to put that in there. Because you have one 9 right or 10 right. You want the total probability. Oh lordy, I got 2.956 times 10 to the -5th. A really, really little number. All right. I don't remember what else on the homework. I will be assigning the homework tomorrow. So it won't be due until Friday. If you have some time and you want to get started on it, we will finish this section up tomorrow.